Hello! To those of you watching this video, we're gonna do an exercise on strains in a bar. Let me read the description of the exercise right away. A bar whose initial length is 70 centimeters is subjected to a tension force F at its ends. Because the material of the bar is not homogeneous, the strain is not constant, but variable as per the strain function epsilon of x is equal to 0.02 plus 0.008x. Compute the total length of the bar in the expanded or the strained state. So, before we start computing the total length of the bar, let's look at this sketch and figure out what's going on in general. We have the bar in the initial state here, which is not yet acted on by the tension force, and here the bar is subjected to the tension force, and as a result, it expands by the length u. L0, that's the initial length of the bar, which is 70 centimeters, and u represents either the expansion of the bar or the displacement of its right end. And our goal is to calculate the total length of the bar in the expanded state. At this point, it is important to remember that the strain of the bar is not constant, because if the strain was constant, it would be very easy to calculate the total length. The strain is variable, and the strain depends on the location x inside the bar. So our x-axis starts at the left end of the bar, and as we go along the bar to the right, that also increases our x value. And the strain, as a function of x, is described by this equation. In this regard, because the strain is not constant, we need to use an integral to calculate the total length of the bar. The strain, in general, is expressed as du over dx. And that's equal to the strain epsilon as a function of x. Now, this equation holds up if the strain is not constant. And if you rearrange this equation into du, you're gonna get du is equal to epsilon as a function of x times dx. And if we want to obtain u, the expansion of the bar, we need to integrate over the whole length of the bar in the initial state over the function epsilon of x, and then dx comes at the end. So we have the information, the initial length of the bar, which is 70 centimeters, and let's start with the calculation. So we're interested in finding the expansion of the bar, and that is u. So I'm just gonna copy this formula here, but this time I'm gonna indicate the integration limits. So we're gonna integrate from 0, where the x-axis starts, to the initial length of the bar, and that's gonna be L0. So epsilon of x is this function, 0.02 plus 0.008x. This function means that if you go to the right, that the strain of the bar goes up. And don't forget dx at the end. Okay, I'm gonna put a bracket here. Okay, so if we want to integrate this function from 0 all the way to L sub 0, let me actually shift this whole thing a little to the left to have more space. So u is equal to, okay, first we need to find the antiderivative of this function. And that's actually an easy undertaking, because the function is linear. It's not going to be too much of a challenge to obtain the antiderivative. So it's going to be 0.02x plus 0.004x squared. That's the antiderivative, and we need to integrate the function from 0 to L sub 0. And if we perform the integration, we're going to get the following. U is equal to 0.02 L naught, or L sub 0, plus 0.004 L sub 0 squared. And then a minus 0, because if you plug 0 into the x, you're going to get a 0. So minus 0, you can just disregard this part here. And L sub 0 in our case is 70 centimeters. Let's just convert it into meters, so it's going to be 0.7 meters. And let's plug that value into L sub 0 in the equation here. And that gives us U is equal to 0.02 times 0.7 meters plus 0.004 times 0.7 meters squared. And that, if we perform the algebra, that is equal to 0.014 plus 0.196, and that's equal to I should plug the meters behind the numbers. Well, you should not leave out the units if you do the math. Sorry for missing them. That's equal to 0.01596 meters. So this is the amount by which the bar is expanding if it's subjected to the tension force F. Now, this is not yet the total length of the bar, because the total length, the initial length is 70 centimeters, and we have merely calculated the expansion, and the expansion is 0.01596 meters. To calculate the total length of the bar, you just need to add together the initial length and the expansion. So that's no longer a big challenge. The total length, which I'm going to indicate as L dot, is equal to L sub 0 plus U. That's equal to 0.7 meters plus 0.01596 meters. Well, this is something that can be done in one's head. 0.71596 meters. And if we express that value in centimeters, it's going to be 71.596 centimeters. So you see, if you have a strain function that's not constant, you need to do the integration to find the total length of the bar. I hope that this exercise was helpful to you, and I will see you again.